Happy Sunday afternoon, geometry students. This is Mr. Lamb, and this is the practice test for circles key. I will be doing 4 straight videos, 1 for each page as we go through. And just remember that there are a lot of these answers that I'm going to give, that there could be multiple other answers. So as I talk about a technique to get an answer, just understand that you may have something slightly different, but it's still right. Well, with that being said, let's go ahead and take a look at question number 1. Question number 1 is broken into 2 parts, an A and a B. Part A looks like 5 different parts, all about naming different parts of a circle. So let's take a look at part A, and I'm using the figure off to the right, and it wants me to name a minor arc. Remember, a minor arc is named with any 2 points, and it has to be less than 180 degrees. So a real easy one here is this little arc from A to C right there. And that arc I could call AC. Don't forget to put an arc above it so you can signify that that is an arc and not a segment. All right, number 2 wants us to name a semicircle. Semicircle takes 3 points. Has to let me know which way to go. In this case, I want to talk left and right, and it's going to make up a diameter. So I'm going to go around this circle from A all the way around to B. That is half of a circle. That's a semicircle. And I need a 3rd letter to let me know, in this case, do I go left through C, or do I go to the right through D or E? And if I wanted to go left, I wanted this semicircle. I need 3 points. Starts at A, goes through C, ends at B, put an arc above it. I could have called it BCA. I could have went to the right and called it ADB or AED or BEA or BDA if I wanted to. Number 3, a major arc. A major arc is anything over 180. So in this case, I'll start at A. And I'll end at E. It has to be more than 180, so my only path would be this way. It takes 3 points, a starting point, a midway point, and an end point. So I'm going to start at A. I go through point C, and I'm going to end at point E. So that is major arc ACE. If you're wondering if you could have called that ABE, you're absolutely right. You could have done that as well. All right, number 4 says the name of the circle. I write the word circle, or I put a picture of a circle. And a circle is always named by its center. So in this case, P is the center. So that is circle P. And then a chord is any segment that has both endpoints on the circle. So I see segment DE, and that is a segment, so it gets a straight line. AB is also a chord. So if you're looking at AB, and AB is a very special chord, it's a chord that is also the diameter. All right, now let's go on to question 1, part B. It says find AB, the distance from A to B. I'll highlight that in green right there. Find the distance from A to B in the given circle. Okay, well, as I look at these 2 circles, I see that from A to E is 10. So the radius of the big circle is 10. So that means the distance from A to D is 10. And then looking at the little circle, I see it has a radius of 3. So B to D inside that little circle is a diameter, which is 6. And then AB is the difference between those 2. Or 4 units. So from D all the way to A is 10, D to B is 6. That leaves 4 of it for the rest. All right, question number 2. it says for circle D, off to the right, NL, so the whole way across is 18. So I'm going to, that means each of my radii must be 9. These are all 9s. Because NL is a diameter, and that means radius would be half of that. The measure of arc NM is 75. Arc LK is 70. And it wants us to find the following, A through F. It says leave answer in terms of pi and simplest fraction or radical form. Okay, that means I'm going to bring up my calculator here. All right. There we go. I just want to have my calculator ready. Okay. So let's take a look over here at letter A. It says find the measure of arc NJL. NJL. Let me highlight this. NJL. Means that arc over there. Well, as I look at that arc, I can see that NL is a diameter. So NJL is an arc made up from a diameter. So I know for a fact that that is 180 degrees. Okay. The next one, measure of arc NKM. NKM. All the way around. Okay, a whole circle adds up to 360. This is everything except 75. So this will be 360 minus 75, which is 285 degrees. Okay. Circumference of the circle. Okay, we know that the formula is circumference equals pi times the diameter. We know that the diameter is 18. So this is 18 pi. And again, when it says leave pi in your answer or leave your answer in terms of pi, don't actually multiply by pi, just leave pi on there. All right. Letter D says the arc length, which means I need to use the circumference, and I need to find the angle for Kn. All right, so Kn. There's Kn. All right, so a couple of things. Let me jump in here and get rid of these 9s in the middle. I'll start looking at some angles. So since arc KL is 70, then angle KDL is also 70, because it's a central angle. And since arc NM is 75, then NDM angle is 75. NL, we can see that that is a diameter, so it's going to be 180, which makes angle MDL 105, because 105 plus 75 is 180. And I think that's all I know right now. All right, so let's find the arc length now for NJK. Well, NJK, this big angle down here is 180. And I can see that I already have 70 of it. So the rest of that angle, this angle right here, has to be the difference between 180 and 70, so it's 110. So this arc is 110 degrees in yellow. At yellow arc's 110 degrees. So I have 110 of the 360 degrees, and I want arc length, so I'll multiply it by the circumference, multiply by 18 pi, and what does that equal? Well, let me jump to my calculator. I want to do 110 out of 360, and I want to multiply that by 18 pi. Now, I'm not going to put pi in. I'm going to leave pi out for just a second. I see 5.5. Let me turn that into a fraction. Math, enter, enter. So 11 over 2. 11 over 2. So this is 11 pi over 2. That is the length of arc KN. All right. Get rid of that. And get rid of this. As I look at E, it says find the area of circle D. Well, area is pi r squared. We know that the diameter is 18, so the radius is 9. And 9 squared is 81. So the area is 81 pi. And the last one, find the area of KDL. KDL, this area right here. Again, very similar to D. I care about the angle of the arc, so that's 70 out of 360 times. Now I'm finding the area of the sector, so I'll take that fraction, I'll multiply it by the area. So I'll multiply by 81 pi. All right, back to my calculator. 70 out of 360, and I'll multiply that by 81 pi. I won't put the pi in yet. Let me get my decimal and then math. Enter, enter. And it's 63 over 4. So 63 pi over 4 for my final answer. All right, it's going down to question number 3. Find the radius and diameter of a circle whose circumference, okay, circumference is equal to pi times diameter. So the circumference is 32 pi equals pi times diameter. Divide both sides by pi. I cancel, and that means the diameter is 32. And then the radius is half of the diameter. So half of 32 is 16. And those will both be measured in meters if you're looking for a label. Now, question number 4. Converting the following. Well, that is what we just finished up. Converting 72 degrees, so 72 degrees. I'm going to multiply this by a fraction that is equal to 1. And since I have degrees on top, I'll put my degrees on the bottom. 180 degrees is equal to pi radians. The degrees cancel, one on top and one on bottom. So this is 72 pi over 180. And I need to reduce that. So 72 over 180 is 0.4. Math, enter, enter. It's 2/5. So this is 2 pi over 5 radians. Letter B wants me to convert 4 pi over 9 radians. And I'm going to multiply by 1. Now I need to get rid of radians, so I'll put my radians on bottom. So pi radians is equal to 180 degrees. And now radians cancel radians. On the bottom I have 9 pi. Oh, hang on. Even better, I can cancel the pi's as well. So on the bottom I just have 9. On the top I have 4 times 180. And this will be in degrees. So 4 times 180 divided by 9. So 4 times 180 divided by 9 is 80. This is 80 degrees. And the last question on page 1, question number 5. It tells us that in circle O, the measure of angle MON is 60. KN is a diameter. And if the measure of LKN is 40, that's an inscribed angle there, what is the measure of arc LM? That's what I'm looking for right there. All right, first thing I'm going to do is I'm going to find this entire arc from L all the way around to N. Because of this 40-degree angle down here, that is an inscribed angle, so that means the opposite arc is twice of its size. So this whole arc up here is 80, which is 40 times 2. I have this central angle, which is 60. So that means the arc inside of here is also 60. So arc LM plus arc MN has to equal arc LN. Kind of like the angle addition or segment addition postulate, it is the arc addition. Well, arc LM, I don't know. Arc MN is 60, and arc LN is 80. So I subtract 60 on both sides, and arc LM is 20 degrees. And that does it for page 1.